Today we're discussing analyzing quadratic functions. We've already talked about what a quadratic function is, so make sure that you've watched that video before you watch this one, or have been in class that day. So today we're going to look at some of the different formats of a quadratic function. A quadratic function doesn't always look the same. Later in the year, we'll be able to find out how to get those different forms, but for now, we're just going to simply use them to get valuable information about our parabola. The forms we're going to look at today are standard form, vertex form, and factored form. At the end of this lesson, hopefully you'll be able to get the information you need to graph a parabola regardless of which form it comes in. Standard form is what we learned last time in our quadratic function introduction. Standard form is our y equals ax squared plus bx plus c. If you recall, we found the vertex or axis of symmetry, the x value for our vertex, using b or opposite of b over 2a. To find the y value of our vertex, we took that axis of symmetry number and plugged it into our formula to find our y value. Some minor things that we discussed: if a, the number in front of x squared, was greater than 0, or in other words positive, the graph opened up and our vertex became a minimum. If a was less than 0 or negative, our parabola opened down and our vertex became a maximum value. Our y-intercept, if you go back and look at your work, was always at 0c. When we plugged 0 into our form, the quadratic term became 0 every time, the linear term became 0 every time, and all we were left with was this lonely little constant c. So a quicker way to look at it now, your y-intercept will always be at 0c when you're in standard form. Now let's take a look at vertex form. Vertex form is written as f of x equals a times quantity x minus h squared plus k. Quantity simply means that I'm going to have something in parentheses. If you look at the vertex is using two numbers that already exist in my form, h and k. I want to quickly caution you about this set of parentheses. When I have to identify h, if I have something in parentheses like x minus 3, that means that my h value is 3. If, however, I see something like x plus 4, because there's a subtraction sign in my equation, that means h is going to be negative 4. It's almost like that negative sign or subtraction sign is saying it's the opposite of what you see here. So if I see a negative 3, h is going to be the opposite of that. If I see a positive 4, h is going to be the opposite of that. Keep that in mind as you go through today's lesson. The axis of symmetry, instead of having to plug a number back into my equation, is simply at x equals h. Same thing with standard form. If a is positive, the graph opens up and my vertex becomes a minimum. If a is less than 0 or negative, the graph will open down and my vertex becomes a maximum. Now we introduce factored form. Very rarely, but occasionally, this will be called intercept form. I will always refer to it as factored form. Factored form of a quadratic looks like f of x equals a times x minus p times x minus q. The zeros, or in other words our x-intercepts, will always be at p0 and q0. That's kind of why it's called factored form. We're going to learn factoring later in the year as a way to find zeros. To find the y-intercept, we're going to substitute a 0 in for our x values and simplify just like we did with standard form. This time the axis of symmetry, if you can think about it for just a second, if I have an x and y axis and I have a parabola, sorry for the crude drawing here, if I have two zeros on my x-axis, my axis of symmetry is going to be exactly halfway between those 2 points. So to find my x value for the axis of symmetry, I'm going to take the average of my two x-intercepts p and q. P plus q divided by 2 will give me my axis of symmetry. I'm going to find the y value of the vertex, just like we did in standard form, by substituting our x value or our axis of symmetry value back into our equation and simplifying. Make sure that you have written down all of these different forms and their features before you go on. Remember, videos have pause and rewind so that you can go back and do that if you need to. So let's take a look at what that is. So for our first example, we're going to suppose that we're launching a bottle rocket and our flight can be modeled by f of x equals negative quantity x minus 1 times quantity x minus 6, where f of x, which recall is the same as y, measures the height above the ground in meters, and our x value represents the horizontal distance in meters from our launching spot where x is 1. How far does the bottle rocket travel? In the horizontal direction, what's the maximum height the bottle rocket reaches? And how far has the bottle rocket traveled horizontally when it reaches that maximum height? We're going to graph the function to help us answer some of those questions. First of all, think about what form this equation is in. Is it in standard form, vertex form, or factored form? Well, this one happens to be in factored form. So when I go back and look at what factored form can offer me, first of all, the zeros or x-intercepts will be at p0 and q0. When I look back at my equation, p will be 1, q will be 6. So when I put that on a graph, I can actually put my points where I have 1 and 6. There's my two x-intercepts. Remember that it said that my axis of symmetry will be exactly halfway in between those 2 points. This point's at 1, this point's at 6. When I add them together and divide by 2, I get 3.5. 3.5 is where I will find my axis of symmetry. I also know my vertex is going to be on that line. So now I need to find the y value of my vertex. To do that, I'm going to plug in my axis of symmetry x value. So I'm going to have negative quantity 3.5 minus 1 times quantity 3.5 minus 6. I always have that negative out front. 3.5 minus 1 is 2.5. 3.5 minus 6 is negative 2.5. When I come up here and get hold of the calculator, when I put that in, I get 2.5 times negative 2.5. I'm also going to be multiplying that by a negative 1 because the negative out front means that this is being multiplied by negative 1. I'm going to get a positive 6.25. That's going to be my y value when x is 3.5. I'm going to rewrite that f of x because the real way to write it would be f of 3.5. So now I know my vertex is going to be at 3.5 and up 1, 2, 3, 4, 5, 6 plus about a quarter more. There's my vertex. I have enough information now to draw in my parabola. I totally missed that point. Never claimed to be a good artist, remember? Sorry about that. Okay, now we can go back and answer some of our questions. Remember, this value up here is 6.25 meters. All right, let's go back and take a look at our questions now. First question says, how far does the bottle rocket travel from launch to landing? It's traveling horizontally. We're going from launch, which is here, to landing, which is at 6. How far horizontally did our rocket travel? From 1 to 6, it traveled a distance of 5 meters. So I'm going to say it traveled, the rocket, this pen is having a hard time. The rocket traveled horizontally 5 meters from launch to landing. The next question says, what's the maximum height the bottle rocket reaches? If we look at our graph, since our vertex is the maximum value, its maximum height was 6.25 meters. So I'll say the maximum height was 6.25 meters. The next question says, how far has the bottle rocket traveled horizontally when it reaches maximum height? So from where our bottle rocket started to where it reaches our maximum height, how far did it travel horizontally? It started at 1. It reached maximum height when x was 3.5, which means it traveled horizontally 2.5 meters when it was reaching maximum height. We already graphed the function, so I don't think we'll have to do that again. All right, let's look at another example. In example 2, we're going to talk about reducing the cost of an item and how that can result in a greater number of sales. How often have you purchased something just because it was on sale, right? The revenue function Revenue, remember, means the amount of money you're going to make. Revenue function predicts the revenue in dollars. R of X is going to represent our revenue. Remember, this is our Y value. Our Y value is going to predict the revenue in dollars. And X value is going to represent each $1 change in price. So X is our change in price in dollar increments. For any particular item, R of X is represented by negative 100 times quantity X minus 7 squared plus 28,900. We want to know what the maximum value is of the function, what the maximum value means as far as this problem is concerned, or the context of the problem, what price increase maximizes the revenue. In other words, how much do we have to increase the price to get the most revenue we can? And what does that mean for the context of the problem? So let's take a minute to graph that function. It's going to make it a million times easier for us in the end. So first of all, what format or what form is this equation in? Was it standard form? No. Was it vertex form? Yes. So let's take a minute to look at the properties of vertex form. Remember, our vertex can be found at HK. Be careful, remember, of the subtraction sign in our form. So when I come back and look at my equation, I still have a subtraction sign here in my form, which means H is 7 and K over here will be 28,900. So first of all, what's our vertex? Our vertex is going to be, since it's HK, our vertex is going to be at 28,900. Do you think my usual graph of 0 through 10 is going to work here? Don't think so, right? So we're going to have to adjust our graph scale to match our problem. Next, what else can vertex form tell us? The axis of symmetry is at x equals h. In this case, x equals 7. So let's put those two things on our graph. First of all, again, we're going to have to adjust for scale. So I'm going to put a little squiggly line saying that I'm skipping numbers. And I'm going to start off with, let's say, 23,000. Then I'm going to do 23,500. My next line, I'm going to do 24,000. Then I'm going to do 24,500. Let's do 25,000. 500, 26,000. 500, 27. 500 and 28,000. One more 0, 500, 29,000. 530,000. I think that's probably high enough. And these down here, we're just going to go by ones. So I'm just going to have 1, 2, 3, 4, 5, 6, 7. Remember, our Y value is our revenue. This is how much money we're going to make. And the X axis was our price increase in dollars. So first of all, we have our axis of symmetry here at x equals 7. My vertex was at 7, 28,900. Remember, that was at HK. So 7 and about 28,900 would put me about there. That's really all the information I have so far, so we have to use some of the other things we know to help us get some more points. For instance, how about y-intercept? Y-intercept is where x is 0. So let's take a look at that. If x is 0, I'm going to get negative 100 times 0 minus 7 squared plus 28,900. 0 minus 7 gives me a negative 7, and negative 7 squared gives me 49 plus 28,900. Negative 100 times 49 gives me negative 4,900 plus 28,900. Adding the two numbers together, I get 24,000. My y-intercept is going to be at 24,000. It's 7 units to the left of my graph. Because this is our line of symmetry, I can put its symmetrical point or its reflection on the other side. 5, 6, 7. And then I can have a rough graph of what this is going to look like. Obviously, this won't be perfect, but it'll give us some idea. Our maximum value up here was 28,900. This was $7 worth of price increase. Let's go back and take a look at our questions. First question was, what's the maximum value of the function? Our vertex was our maximum value, so our max was at 28,900. What does that maximum value mean in the context of the problem? Well, our 28,900 was a y value, right? Y value represented the revenue in dollars. So this $28,900 as a maximum value means that you could make up to 28,900, but no more. Second question says, what price increase maximizes the revenue, and what does it mean in the context of the problem? On our graph, when I had my maximum revenue, how many dollars had I increased the price? $7 according to my graph. So what price increase maximizes our revenue? A price increase of $7. What does it mean in the context of the problem? If I increase my price by $7, I would get maximum revenue of $28,900. Make sure you're writing down any questions to bring them to class. We'll do our last final example on factored form in class. Have a great day, and I'll see you tomorrow.